In this question it is given that 30 gram of ice at 0 degrees Celsius and 20 gram of steam at 100 degrees Celsius are mixed. The composition of resultant mixture is, so over here we are mixing 30 gram of ice at 0 degree Celsius. So we can just consider that there is 30 gram of ice at 0 degree Celsius. And on the other part we have 20 gram of steam at 100 degree Celsius. The composition of resultant mixture is, so we know that there will be a transfer of heat energy from steam to ice. So just see what is going to happen in the final stage. So we can just observe it stage by stage. So as the ice is absorbing heat energy, there is a possibility, it's not compulsory, that ice may converted into water. Like that, there is a possibility as the steam is like we are taking heat out of steam, so that steam may converted into water. So we don't know which process is going to take place. We can just find out what about the value of heat energy required for both the processes. So first stage, we'll assume that the 30 gram of ice at 0 degree Celsius is converted into 30 gram of water at 0 degree Celsius. So we can find out how much amount of heat energy is required for this process. We'll write this Q is equal to M into latent heat of fusion, let's say LF. So we can write this as mass is given as nothing but 30 and latent heat of fusion is nothing but 80. So we can write this as around 2400 calorie of heat energy is required for this conversion process. Now we can identify whether this much amount of energy can be supplied by the steam or not. So just see these, if the steam is converted, if the steam at 100 degrees Celsius is converted into 20 gram of water at 100 degree Celsius. So we can use this equation, Q is equal to M into latent heat of vaporization. Mass is given as nothing but 20, and we know that latent heat of vaporization for steam is nothing but 540. So you can write 20 into 540 will give the value of heat energy that we need to take it out from the steam to convert into water. So I'll get the value as around 10,800 calorie of heat energy. That means to takes place this process, 10,800 calorie of heat energy should be removed. But for this conversion process, only 2,400 calorie is required. That means this process will takes place, and this process will not takes place. Means steam will supply, some amount of steam will converted into water, and that amount of heat energy is used for this conversion of ice into water. So this process is completely going to take place, and this process is not going to take place. So we'll continue over here. Now next part, we can observe that this 30 gram of water at 0 degree Celsius is going to converted into, the next possible thing is this may convert it into 30 gram of water at 100 degree Celsius. So we can identify how much amount of heat energy is required for this process. As there is a change in temperature, we can use this equation M as delta T. M is 30, specific capacity of water is 1, and delta T is from 0 to 100, we can write it as 100. So we can write this required 3000 calorie of heat energy. So for the entire process, for the first process 2400 is required, second one 3000 is required. The total becomes equal to 5400 calorie of heat energy is required. And this steam can supply up to 10,800 calorie. Again, we can say that this process is going to take place. Now we can observe that it is water at 100 degrees Celsius, and over here it is steam at 100 degrees Celsius. So the entire steam is not going to convert it into water, because to convert the entire steam into water, we need to take this much amount of calorie of heat energy out of it. But we are just taking only 5400 calorie of heat energy from this steam. So entire steam is not going to get converted. Now the water is at 100 degrees Celsius and steam is at 100 degrees Celsius. So there is no difference in temperature. So there will not be any flow of heat energy. So now we can say that 30 gram of ice at 0 is ultimately converted into 30 gram of water at 100 degrees Celsius. So we can say that now the mixture consists of 30 gram of water, 30 gram of water at 100 degrees Celsius. This is one part. And 5400 calorie of heat energy is used. So we can identify how much amount of steam is converted into water. So the ice is absorbed 5400 calorie of heat energy, and by using that, let's say m mass of steam is converted into water, so we can write m into 540. So if we are cancelling this, we'll get as nothing but m is equal to 10. So I'll get the value of m is equal to nothing but 10 gram. That means 10 gram of steam is converted into water at 100 degrees Celsius. So we can add that also. So 30 gram of ice converted into 30 gram of water at 100, and 10 gram of steam is converted into 10 gram of water at 100 degree Celsius, and remaining the total the amount of steam was 20 gram. 10 gram is converted. The remaining 10 gram of steam, 10 gram is in the form of steam only. So we can write now this mixture consists of total 40 gram of water. It consists of 40 gram of water, 40 gram of water at 100 degrees Celsius plus 10 gram of steam at 100 degree Celsius. That is the final composition.